All right, ladies and gentlemen, we're looking at Station 3. And Station 3 has in common what? What's all in common about everything? They're all taken to what kind of power? Fractions. Fractions power, right? Okay, so let's see what that looks like. All right, I know when I take x to the 1/2, I get an error, it says error, all the way to 0, correct? And then at 0, I get 0. At 1, I get 1. At 2, I get 1.41421. At 3, I get 1.73205. At 4, I get 2. And at 5, I get 2.23607. Okay, let's look now at when I take it to the 1/3, what happens? Okay, when I take it to the 1/3, I actually get numbers for these. I get negative 1.70998. I get negative 1.5874. I get negative 1.44225. I get negative 1.25992. I get negative 1. I get 0. I get 1. I get 1.25992. I get 1.44225. I get 1.5874. And I get 1.70998. All right. Okay, so let's look at the differences for the first one when I take x to the 1/2. Let's see if I get anything that looks even slightly what I need. 0 to 1, I added 1. 1 to 1.41421, I'm adding 41421. Okay, now I need my calculator for the next 1.73205 minus 1.41421. I added, from here to here, I added 0.371784. From here to here, so 2 minus 1.73205. I got, please don't talk while I'm talking. Please check my answers, see if you got the same thing. I got 0.26795. From here to here, I got 0.23607. Okay. All right, so that was my first difference. Let's check the second difference. It was taken to the 1/2 power. So that seems a little bit like when we take it to the second difference, right? Maybe? Okay, so let's try to figure that out. All right. 1 minus 0.41421 means I subtracted 0.58579. To get from here, I took 0.31784 to get to 0.26795. I subtracted 0.04989. This is subtraction. To get from here, 0.26795 minus 0.23607. It was 0.03188. Well, none of those are the same. Do you think I'm going to get the same thing? Okay, I don't think I am either. I want to point something out to you. When I take something to the 1/2 power, so I took 4 to the 1/2 power and I got 2. But I took 1 to the 1/2 power and I got 1. What distinct it's doing. If we're not multiplying by 1/2, we're taking to the 1/2 power. Can you guys think of anything else it could possibly be? Okay, 1 divided by 2 is 1/2 though. How can it also be 1? Anybody have any ideas? I want you guys right now to take out your graphing calculator. Everybody should have one in front of you because I've already mentioned that. Make sure your graphing calculator is all clear. The graph in the calculator is all clear. And I want you to put in x to the 1/2. Yeah? And then I also, on the next part, I want you to put another graph on the same graph. I want you to put the square root x.
Wait, what?
I want you to put two things, x to the 1/2 and square root x. It is exactly the same. So taking something to the 1/2 power is like square rooting. Let's see, does this make sense? What's the square root of 0?
Oh, it's the same thing.
What's the square root of 1? What's the square root of 4? Okay. So that makes sense, take it to the 1/2 power. Okay, what would x to the 1/3 mean then? I'm cube rooting it. So Kyle had the right idea, he just didn't have the right word. And this is how we do the cube root. Okay? If you see something like the cube root of x, that's x to the 1/3 power. Okay? Yeah, there's a little nx on there. But you can just take it to the 1/3 power. Well, let's see what that means. What is the cube root of 8? Let's go to the calculator part of your calculator. Let's go to the calculator part of the calculator. Not a graph, but a calculator part. And let's try an experiment. Let's take 8 to the 1/3. Okay, what do you get? 2. All right, what do you think the opposite of taking something to the cube root would be? Like, the opposite of square rooting is squaring. So the opposite of cube rooting would be cubing. Okay, what's 2 times 2?
4
times 2 is? Okay, so that's undoing what I just did, yeah. Okay, so we have learned that the opposite of square rooting is squaring. We've already talked about that because we square root something to get rid of the little square symbol. We've talked about the opposite of cubing is cube rooting, or vice versa. So that's what these things mean. Do we have a question for that? Okay, what do you think that would be? We've got x to the 1/4 power. It'd be to the 4th root. I would call it a 4th root. Could. I don't know what that's called. I can look it up for you. And x to the 1/5 power is the same thing as the 5th rooting. Okay? So if you take something, if you have something like this, let's say you have 64 equals x to the 4th power. So you would 4th root it. Okay? Or, if you can't 4th root it in your calculator, what would I change this to? Instead of 4th root, I would take 64 to what? 1/4. Let's see what that is.
How do you do that?
So we put in our calculator 64. We push the caret up button, which is underneath the equal sign. Parentheses. 1 divided by 4 and parentheses. 2.82843. So 64. The caret button, which is right under the equal sign underneath the L sign. Parentheses 1 divided by 4.
See, that's what you do.
Okay, are you guys kind of getting why these are important? Because in Algebra 2, when you take it, you're going to get things like this. where it says, you know, you get at the end, 64 equals x to the fourth, you got to know what to do. You take it to the fourth root. A lot of times your calculator doesn't have a power where you can stick in the root, so you have to do that. Okay, so to get full credit on your differences sheet, you have to at least have every table filled in. You have to have the first differences for everything, and at least show that those don't make any sense. Okay? And I would at least like you to do on this, the first one, have the second differences, because I just had that up in the morning. Okay, let's go through and answer our questions on the next page. All right. Here we go. How do all the graphs compare to each other? Do they all look the same? So if you flip through your packet and look at the 4 graphs at the top of each page, they do have a fraction of a power, but what do the graphs look like because of that? They all cross where? They all hit the x-axis. So all the whats are the same. When you touch the x-axis, we call that a what? No. What do we call that? Come on. When you have a parabola and it crosses the x-axis, we call those the, that's the bottom of the x-axis. What do we call it? The roots. All have the same roots. They all have the same roots. Okay. What effect did P have on the graph? So, let's talk about that. If the power, or P, was even, what did the graph look like? So look at your packet. What did the graph look like? If I took it to the 1/2 or I took it to the 1/4, did it have 1 arc or did it have 2? Let's look. If it's not true. 1. If P was even, it had no negative answer. So if P was odd, it had what? It had both positive and negative. Why do you think that is, guys? I want you to try something else in your calculator. Okay? -1 squared, what do you get? -1 to the 3rd power, what do you get? What's -1 squared? +1. What's -1 to the 3rd power? What's a negative times a negative? Times a negative becomes a negative. So maybe that's why when we take something to the 3rd power, we're timesing it again by a negative, or the 1/3 power?
I know that all even numbers positive and odd numbers.
That is correct, Jeff. Hence why we have only positive when it's even and positive and negative. Okay. What effect does A have on the graph? We keep talking about this. A makes it go closer to the x-axis or further away. Will you get that, Miss Hart, for me?
Oh, get out of here.
Is Murphy's room? Hi.
What else does A do? What if A is negative? What happens? It flips it under.
I mean, it was right. Okay.
Yeah.
All right.
If A is negative,
It will be.
it flips over x-axis. Okay, where did A show up on all of your tables? When x was what? Try again. A shows up when x is 1. Okay. Did the differences relate to the equation in any way, shape, or form?
No.
No. So what can we we can